Good morning. Okay, so you learned how to solve a linear system using the method of substitution. And now we're going to take it a step further, and you're going to solve real life situations that involve linear systems, and you're going to solve them using substitution. So by the end of today's lesson, you will be able to solve real life world problems involving linear systems using the method of substitution. So I've handed you out a little piece of paper. Could you solve that linear system on the piece of paper using substitution as your mind's on today? You're not going to do anything in your AFL booklet. So pause the video if you haven't solved it already and go ahead and solve this linear system. Okay, so let's do it. Let's solve this linear system using substitution. So this one's a pretty straightforward one because it's in y equals and y equals form already, which means that you've already got one variable isolated in each equation. And so you can choose to substitute this one, this side of the y, over here, or you can substitute this over here. It doesn't matter. It's going to result in the same thing. One of these is equal to one of these. So you're going to end up with x minus 7 equals 2/5 x minus 4. Now the fractions aren't so nice, but you can use your fraction key on your calculator. So this is going to be x minus 2/5 x when I bring all of the x's to one side and then all of the numbers to the other side. When I combine the invisible 1 that's here, on your calculator, you're just going to do 1 minus 2/5. Well, 1 is like 5/5, so 5/5 minus 2/5 is 3/5. So 3/5 x equals 3. And then when we divide both sides through by 3/5 to get x by itself, we end up with x equals 5. And here I'll just show you 3 divided by 3/5 is the same as 3 times 5 over 3. When you take the reciprocal of that fraction, the 3's cancel and you're left with 5. Okay, so that was the hard part. We know that x equals 5, and now we can just substitute back into the original, one of the original equations. So I'm going to say sub x equals 5 into y equals x minus 7, and I end up with y equals 5 minus 7, y equals negative 2. So my possible, here I'll just go up here, so the x is 5, the y is negative 2, that's a possible solution. And now we need to check. So we'll check the first one. It's very likely that that one's going to check because that's the one we used to find y. So negative 2 equals 5. And here I'll just put what I'm checking. I'm checking the point 5, negative 2. So negative 2 is my y. X is 5. Minus 7 is up here. So then we get minus 2 equals minus 2. And left side equals right side. So far so good. Let's check the other one. Y equals 2/5 x minus 4. So y equals 2/5 x minus 4. I'm going to substitute in the negative 2 here. 2/5 times 5 for the x minus 4. Okay, so let's see. We can do this. 2/5 times 5. You can do it on your calculator if you like. Or you can just notice that this is like 5 over 1, and the 5s would cancel, and you're left with just 2 here. So this is minus 2 equals minus 2, and left side does equal right side, so we can conclude then that the point 5, negative 2, is the solution to the linear system. Okay. So that's substitution, and that was a pretty easy one because the substituting part was fairly straightforward because they were both originally in y equals form, right? All right. I'll just go back in case you didn't copy that. You need to pause it. Okay. Let's get on with today's lesson. So here's a word problem. Megan is turning 16 and her parents are planning a party. Tony's Pizzeria charges $150 for the party room and $12 per guest for the cost of the food. Hamburger Joey charges $180 for the party room and $10 per guest. So this is a real life situation that you may encounter in your lifetime when you're trying to make a decision that's in your best interest. And it's hard to tell because everybody changes up slightly just to confuse people their methods for charging for something like this. And they're just relying on you not to really understand the subtle differences. It seems like, wow, it's only $10 per guest for Hamburger Joey, right? It's cheaper. Or is it because they're charging more for the party room? Will it be cheaper? Well, it really does depend on how many guests are attending. So it says write a linear system of linear equations to represent the situation. So let's do Tony's Pizzeria. So I'll call it TP. Not toilet paper. Tony's Pizzeria. All right. So I'm just going to over here let C represent the total cost of the party in dollars. And I don't know, do you want to, how about N represents the number of people then? At the party. Okay. So, when we're writing our first equation for Tony's Pizzeria, we can see that they charge $150 for the party room and $12 per guest. So the number of guests times 12 is going to be a big part of that cost, but there's also that fixed cost of $150. So the total cost is C. I'm going to put the 12 times the number of people first plus 150. So this is kind of like our sorry about that. Just pause for a second. This is like our y equals mx plus b form, right? And then Hamburger Joey also has a cost, and it's $10 per guest plus $180. So there we go. We've got our two equations. So this represents a linear system. We could graph these two equations, and we could locate the point of intersection where it will cost the same for a particular number of guests for either Tony's Pizzeria or Hamburger Joey's. So we want to do the same thing now. It says how many guests must attend for the charges to be the same, but we're not going to graph it to find the point of intersection. We're going to find the point of intersection by using substitution. So again, I'm going to look at the right hand side. I can see that the C is already isolated, so I can take this, which represents C, and I can replace C in the second equation with it. Okay, so that's what I'm going to start to do. So I'm going to say 12n plus 150 is equal to 10n plus 180. Now I've got everything in terms of just n, no c's, and I can solve for n. So I'll bring the 10 over. 12n minus 10n equals 180 minus 150. 12n minus 10n is just 2n, and this is 30. I'm going to divide both sides through by that 2 to isolate the variable, and I end up with n is 15. What did n represent again? We can always go back to our let statement to make sure we know what we're talking about here when we say that n is 15. So n represents the number of people at the party. So the question was, always go back to the question, how many guests must attend for the charges to be the same? Well, I've solved. That is the point of intersection. That is where the number of guests are going to be the same and the charges will be the same. So I can stop here. I don't have to find the cost. It didn't ask me to find the cost. So I'm going to say, therefore, if 15 people attend, the cost will be the same at either restaurant. Okay. Now, there could have been wait, I'll double check. Oh, no, there's no more questions here, but there could have been another question that said, oh, when is it best to attend? When would it be better to choose Hamburger Joey's? Because we know it's the same for 15 people, but is it cheaper then for Hamburger Joey's when it's less than 15 people or more than 15 people? And so you would kind of have to look at the slopes of the two lines. This, I was going to say toilet paper. Tony's Pizzeria has a slope of 12, and Hamburger Joey's has a slope of 10. So one is less steep than the other. So if we were trying to figure out when, so this is going to be Hamburger Joey's, this is going to be Tony's Pizzeria. This is where, if 15 people attended, the cost would be the same. So you're better off moving forward if you thought you were going to have more than 15 people attend, going to the lower, the less steep graph on the right of this point. So here it would be Hamburger Joey's because the slope was 10. This was Tony's Pizzeria. They charged a little more per person, right? So the slope was steeper, and it would not be a good idea to go there because it's going to end up costing you more. Okay, so you can always analyze based on the slopes to determine whether it's better to choose one over the other if you have more or less than the solution in terms of the number of people. Okay, let's move on. Okay, a cotton candy machine was rented for the school fun fair. It costs $120 plus $1 per serving for supplies. The student council plans to sell cotton candy for $2.50 each. Let C represent the cost of the candy, and let N represent the number of servings sold. So it says write an equation to show the total cost for operating the cotton candy machine. So what does it cost? It costs to rent the machine $120, and then to buy the supplies it costs $1 per serving. Okay, so I'm going to say that the cost is going to equal, I'll write the 1 in for now, so 1N plus 120. So $1 per serving plus 120 for the fixed cost, and that's the total cost. So I'm not going to put the final, in my final answer, I'm not going to put the 1N in, I'm just going to put N. And then it says, write an equation to show the revenue made from selling the cotton candy. Well, revenue is the money that you take in. Revenue is not the same as profit. So if we go to I usually give a pizzeria example. If you have a pizzeria, your revenue is the money that you have in your cash register at the end of the day. That's your revenue. But your profit is the money that you have, that you get to take home at the end of the day. You don't get to take home all of the money in your cash register because you need to pay for the dough, and you need to pay your employees, and you need to pay the hydro, etc. So profit is revenue minus expenses. Okay, so revenue is just all the money that you're going to make. And so how do they make their money? They're going to sell the cotton candy for $2.50 each. So their revenue, call it R, and I'll just make a little let statement here. Let R represent the revenue in dollars. Okay, and so R is going to equal the amount that you sell one serving for, $2.50, times the number of servings that you're going to actually sell. Okay, there we've got a revenue and a cost. So how many people must buy cotton candy in order to break even? Well, break even means that you're not making any profit, that your revenue is equal to your cost, or that your profit is equal to zero, right? You're just breaking even. So when is revenue equal to cost? Well, we can set them equal to each other, right? If costs and revenue are the same, then this is like calling this cost. And so if we had a C and a C here, we could replace the C with this. So I can just set these two equations equal to each other and solve for n. So if I move the n to this side, I'm doing that specifically because I want to avoid having a negative n. 250 minus the invisible 1 in front of that n is going to be 150. And that's 150n, and I've got 120 over here. So when I'm going to divide through by $1.50 on both sides to solve for n. So $1.50 here, 1.5, so or $1.50 here. And what we're left with then when we do this is just n and 80. So n equals 80. So let's see, what did n equal again? We let n, at the very beginning in the original question, n represented the number of servings sold. So how many people must buy cotton candy in order to break even? We've actually solved the problem already. Therefore, we can say 80 people must buy cotton candy, because that's the number of servings, to break even. And of course, if more people buy cotton candy, they're going to make a profit. If less people buy cotton candy, they're going to lose money. Okay, that's it. That's all we're doing in terms of solving word problems using substitution. So it's pretty straightforward. It's not that difficult. You've got lots of time to do some homework. So please do the No, do we have a consolidate? We don't have a consolidate today. So you're going to dive right into your homework, your textbook work. It should be on your handout. Thanks for listening.